Is AI actually smart, or is it just really, really good at guessing? You've probably heard this explanation before. ChatGPT doesn't think, it just predicts the next word. Fancy autocomplete. And technically, that's not completely wrong, but there's a problem. If predicting the next word is so simple, why can the same system write Python code, explain quantum mechanics to a 12-year-old, translate Japanese, analyze images, and solve problems it was never explicitly programmed to solve? At some point, we have to ask a strange question. How good can guessing become? Before we start calling it intelligence, imagine I give you a sentence. The capital of India is, you probably thought, Delhi or New Delhi. Congratulations. You just predicted the next word. Now try this. John left an ice cream on the table for 3 hours. When he returned, it had melted. Again, you predicted what comes next. But to make that prediction, you used knowledge. You know what ice cream is. You understand temperature. You understand time. Somewhere in your mind, you built a model of the situation and predicted the answer. This is where the AI debate gets interesting. Modern language models are trained using a surprisingly simple task. Give the model some text, hide the next piece, ask it to predict what comes next. I am watching YouTube, maybe it's video. At first, the model is terrible. Its predictions are almost meaningless, but it tries again and again across enormous amounts of text. And to get better at predicting language, something interesting happens. The model starts learning patterns inside language. Grammar, facts, relationships, programming syntax, writing styles, and even patterns that look a lot like reasoning. Think about it. If a model repeatedly sees Marie Curie connected to physics, chemistry, radioactivity, and the Nobel Prize, those relationships begin to form inside its mathematical network, not as a Wikipedia page hidden somewhere in the AI. Instead, the information is distributed across billions of adjustable numbers called parameters in a giant multidimensional space. So saying an AI is just predicting the next word can be misleading. A chess player is also just choosing the next move. But the interesting part is the enormous amount of mental reasoning and thinking required to choose a good move. The output doesn't tell you everything about the process that created it. But does this mean AI thinks like a human? No. And AI gives us some spectacular evidence of that. A powerful model might generate hundreds of lines of working code, then confidently fail a simple logic problem because of one tiny trap. It might explain Einstein's theory of relativity, and 5 minutes later cannot figure out the larger number between 0.6 and 0.11. It may sometimes say 0.11 is larger than 0.6. We call this hallucination. The reason is important. A language model is trained to produce a plausible continuation. Plausible does not always mean true. Ask, who was the first person to grow coffee on Mars? There is no correct historical answer, but an AI might recognize the shape of the question. A person, a discovery, a date, a place. And if the model isn't careful, it can generate an answer that sounds completely legitimate. The sentence feels right. The facts are completely wrong. This reveals something important. Fluency is not the same as intelligence, and intelligence is not the same as truth. But here's where things get even stranger. In 2017, Google researchers published a paper called "Attention is All You Need." It introduced the transformer architecture that helped reshape modern AI. One of its key ideas was attention. Very simply, attention helps a model determine which pieces of information are important to each other. Take this sentence. The trophy didn't fit inside the suitcase because it was too big. What was too big? The trophy. Now change one word. The trophy didn't fit inside the suitcase because it was too small. Now what's too small? The suitcase. The sentence structure is almost identical, but the meaning changes. To predict the correct language, the model benefits from learning relationships between words and concepts. Then researchers scaled these systems. More data, more computing power, larger models, tweaked architecture, and their capabilities improved. Translation got better, coding got better, question answering improved. Performance on many reasoning and knowledge benchmarks increased. This creates a bizarre situation. We gave machines one basic training game, predict what comes next, and to become extremely good at that game. They learned surprisingly useful representations of language, code, science, and parts of the world described in text. But do they actually understand any of it? This question is much harder. There's a famous thought experiment called the Chinese room. Imagine a person locked inside a room. They don't understand Chinese. People outside send Chinese symbols into the room. The person has a gigantic instruction book. If you see this symbol, respond with these symbols. They follow the instructions perfectly. To a Chinese speaker outside, the responses look intelligent, but the person inside understands nothing. Critics of AI argue that language models are doing something similar. Symbols go in, mathematics happens, symbols come out. No real understanding, but there's a counterargument. A single neuron in your brain doesn't understand English either. It receives signals, responds, and passes signals forward. No individual neuron knows what a dog is. Yet roughly 86 billion neurons working together produce a brain capable of understanding the sentence, "I saw a dog." Complex abilities can emerge from simple components interacting at enormous scale. So maybe AI has developed some form of machine understanding. Or maybe it is performing the greatest imitation of understanding we've ever created. We genuinely don't have a universally accepted answer. What we do know is that AI can now perform useful tasks once strongly associated with human intelligence. AI systems write software, analyze complex data, solve mathematical problems, and assist scientific research. AlphaFold, for example, transformed protein structure prediction and has made predictions available for more than 200 million protein structures. That's not a chatbot party trick. That's useful scientific work. But AI still has a major limitation. Humans don't learn only from text. A child learns gravity by dropping a spoon, again and again. Humans touch things, move through space, feel pain, experience hunger, interact with the physical world. An AI can read a million descriptions of pain without necessarily experiencing pain. It can write, "I'm happy to help," but that does not prove happiness exists anywhere inside the machine, and this distinction matters. Intelligence, understanding, and consciousness are not necessarily the same thing. A calculator is better than you at arithmetic. We don't assume it's conscious. A chess engine can defeat the world's greatest players. We don't assume it feels proud. AI may be intelligent in some ways, without having anything resembling human subjective experience. And here's the final twist. Humans are prediction machines too. When you catch a ball, your brain estimates where the ball will be. When someone says, "Happy birthday to," you're already expecting the word "you." While listening to this sentence, your brain is constantly predicting what might come next. Prediction is deeply connected to human cognition. So the argument AI predicts, therefore it cannot be intelligent, may be too simple. The real question is, what happens when a machine becomes unimaginably good at prediction? Maybe, to predict the world accurately, a system has to build some kind of internal model of it. Not a human model, not consciousness, but a mathematical representation powerful enough to capture relationships, patterns, and rules. So, is AI actually smart? The answer is frustrating in some ways. Clearly yes, in other ways, spectacularly no. Maybe AI doesn't think like us, but an airplane doesn't flap its wings like a bird, and it still flies. We taught machines to guess the next word, and somehow in the process, they became good enough to write code, solve problems, assist scientists, and make us question what intelligence actually means. Maybe AI is just really good at guessing, but perhaps we underestimated how powerful guessing can become. That's all for today. Thanks for watching Dots and Arrows.